This method can help provide key fabrication techniques in the microfluidics field, such as for the manufacturing of channels with different geometric cross-sections in a polydimethylsiloxane polycarbonate microfluidic device.
The main advantage of this technique is that the microfluidic channels can be fabricated through a one-step approach by sequential wet etching processes without tedious procedures and extensive alignment.
The implications of this technique extend toward development of complex microfluidic systems because fabrication processes for channels with non-rectangular sections or various heights can be significantly simplified using this method.
Though this method can provide insight into microfluidic device fabrication, it can also be applied to other desired microenvironment conditions, such as flux distribution or mixture of substance in channels.
Begin the procedure with a prepared master mold. In this case, the negative mold created with photoresist is on a 4-inch silicon wafer. Here is a computer-aided design image of the inverted topology for the channel layouts. Proceed by combining PDMS and its catalyst in a clean plastic cup and mixing it in a power stirrer. When the mixture is homogeneous, put the cup in a desiccator connected to a vacuum pump for 60 minutes. After retrieving the PDMS mixture, take it to the master mold. Pour 20 grams of the mixture on top of the mold. Try not to introduce any bubbles. Next, obtain a petri dish and pour 30 grams of the PDMS mixture into it.